Ladies and gentlemen, eyes up. All bets are off now. This is Count It In. How many arrangements can be made using 3 identical red flags, 2 identical yellow flags, and 2 identical blue flags? We are assuming here that we are going to place all these flags in just one row, and we have here a total of 7 flags. However, take note that our flags here are only differentiated by 3 colors, and for each color, they are actually identical. If we talk about permutation, we are looking into the number of ways that we could arrange objects in that simple or just short or a small rearrangement of objects is automatically different from the previous one. But here, we can see that there are identical flags. Just for the instance, red flags. What if the first arrangement involves 3 identical red flags, 2 yellow and 2 blue flags, and then the second would be for me to rearrange the first and the second red flag. Now that is not distinguishable because it's an identical red flags. This is the time where we are going to use a specific formula for the number of permutations or number of distinct permutations. This is our formula here. Our permutation, number of arrangements, talks about a ratio of your n factorial. Your n talks about the number of flags here. So you have here 3 red, 2 yellow, plus 2 blue. So you have here 7 flags. This will be divided by the number of permutations for each identical object, in this case identical color. So let's just simply use here, say for example, r factorial. That means the number of red flags. We have here y factorial, number of yellow flags, and let's say blue factorial here. So this is how we solve for the permutations or distinct permutations of objects where there are identical objects or alike objects. So our R here, we have 3 red flags. Our Y, we have here 2 yellow flags, and our blue, we also have 2. Now the total of all these 3 must match our given n. So the result here would be simply placing here 7 factorial over, you will have here 3 factorial times 2 factorial times 2 factorial. Okay. Take note that if we have a certain n factorial, it's a condensed way of writing products of integers from 1 to n. Or in reverse order, we have n times the number before it, n minus 1, times the number before it, n minus 2, until we reach 1 here. This would mean that for our numerator, this is just equal to 7 times 6 times 5 times 4, and let me end at 3 factorial. Now aside from there's no space here, I could do that because I also have a factor of 3 factorial here at the bottom. Of course, it's 3 factorial times 2 factorial times 2 factorial, right? I could simply cancel 3 factorial in this one here without extending it further. Okay. Aside from that, our 2 factorial is just equal to 2 times 1, which is equal to 2. This is also true for this 2 times 1, which will give us 2. So our remaining denominator is 2 and 2. I could automatically input all of this in a calculator, but it's easier for me manually to look into the possibilities where my denominator could be equal to 1. Because 2 times 2 is 4, I also have 4 here, so I can simply cancel all these 3. What remains now are the numbers 7, 6, and 5 that is placed on my numerator, and that would tell us the number of distinct arrangements of these 3 identical red flags, 2 identical yellow flags, and 2 identical blue flags. We have 7 times 6 times 5, we have a result of 210 possible arrangements, because we are placing them in one singular row where all of these 7 flags will be placed. So we have 210 possible arrangements. We do this because, again, we have identical objects. So we use this formula for n distinct permutations. And that's count it in. Talking about getting the luck of the draw. For all in, subscribe now.